Okay, so welcome. This is Simon speaking again. I'm just going to go through another example for the simplex algorithm for decision maths on the Edexcel syllabus. Last time I went through a video on how to use the graphics calculator to help you solve a simplex problem. This time I'm going to go through how to do the two-stage simplex method in the exam. So first off, how do we know if this is what we need to do? First off, we might get told in a question. If we're not told, we can see here, this is the example we're going to work through. These two inequalities here tell us that we need to be doing two-stage, because those are greater than or equal to. Now, there are two different methods that we need to worry about in Edexcel, I think in any syllabus. The first one is two-stage, the second is big M method. We're going to go through the two-stage today, but they do the same thing, just in slightly different ways. So first off, we need to think, okay, how do we change our inequalities into equations? So the first one, this x plus y plus 2z is less than or equal to 10 is fine, because we just do that one as normal. X plus y plus 2z plus s, now I'm going to call it s1 and you'll see why later, is equal to 10. Okay, so that one's all fine. The problem comes with our others. So we can see that here in our second inequality we are greater than or equal to. Now for here, for this one, we needed to increase x plus y plus z to get it to 10. Here we need to subtract a different variable, what's called a surplus variable, to get down to 5. The problem with that is the initial solution, or the basic feasible solution, would ideally be the origin. Now, because these are greater than or equal to's, the origin is not a basic feasible solution. This is called a surplus variable. This is slack. This is surplus. The problem with this is, if x, y, and z are all equal to 0, we get s2 equals minus 5. Now, all of our extra variables have to be greater than or equal to 0, which is a problem. So what we do is we then introduce another variable. Okay. This one we're going to add on, so we're going to get 2x minus 3y plus z minus s2 plus a1 equals 5. The a1 is known as an artificial variable, and that's how we deal with these greater than or equal to's initially. So let's continue with the main question itself. So we've already got this second one, so 2x minus 3y plus z minus s2 plus a1 equals 5. The next one we need to do the same thing, so we get x plus y minus s3 plus a2 equals 8. So s2 and s3 work in a similar manner to slack variables for the normal simplex algorithm. But we also have these a variables. Now initially the a variables have a value. So what we need to do is we need to start by minimizing a1 and a2. If that we can do simplex to reduce the total value of A1 and A2 to 0, we then can find a basic feasible solution to then solve this problem here. If A1 plus A2 isn't 0, then we can't do this question, because Simplex only works if we have a basic feasible solution. So we are going to try to minimize A1 plus A2, which means maximizing minus A1 plus A2. So let's give that variable a name. So we can let I equal minus A1 plus A2. So this is our goal now. Okay, with the first stage of the two-stage simplex is we want to maximize this. Okay, now the problem is currently A1 and A2 are our basic variables. We cannot have basic variables in the objective function. So what we need to do is rearrange these two equations here and then substitute things in. So A1 is the same as 5 minus 2x. So A1 is 5 minus 2x plus 3y minus z plus S2. Just rearranging this equation here. We then rearrange this one, so you get plus 8 minus x minus y plus S3. Okay, so I is going to be minus 13 minus 3x plus 2y minus z plus S2 plus S3. And then if we rearrange like we normally do with Simplex, we want to keep the numbers on the right hand side and everything else on the left. So we're going to get I, so minus minus becomes plus, so then we minus 3x plus 2y minus z plus S2 plus S3 equals minus 13. The fact that we're trying to maximize a negative value means it's fine that this is minus. So what we do now is we now set up our initial simplex tableau. So we have basic variable x, y, z, S1, S2, S3, A1, A2, and value. Now obviously there's lots of variables here, so when we go to do our iterations, we're going to need to be a little bit more conservative with the space on the page because we need our row operations column, but for now we're fine. Okay, so we fill in like we normally would. So top row, let's use the first inequality. So we've got 1x, 1y, 2z, 1s1, no s2s, no s3s, no a1s, no a2s, and a value of 10. Okay, second equation, we're going to have 2 minus 3, 1, no s1s, minus 1s2, no s3s, 1a1, no a2s, and 5. Okay, we then have 1x, 1y, no z's, no s's, no s1s, no s2s, minus 1 s3s, no a1s, 1 a2, and a value of 8. And now we can see what our basic variables are. First row is s1, second row is a1, third row is A2. Now this is where things get a little bit weird. We need to include our P function in our table, because while we're changing the rows and columns to maximize I, we are also changing P as we go. Okay, you don't have to have P all the way through, but you're going to have to change it anyway, and it's just easier if you have it there from the start. So we're going to put P in here, and we rearrange it like we normally would. So if you remember, looking back up here, P is 3x minus 2y plus z. So rearranging like simplex before, we have P minus 3x plus 2y minus z equals 0. Okay, so that's going to go on our table like before. Okay. We now put in our I row. We've got minus 3x's, 2y's, minus 1z, which should be the same. Should it? No, I think that's just a coincidence with this particular example that those are the same, but oh well. If it happens, it happens. Okay, anyway, we've got no S1s, one S2, one S3, no A's, and a value of minus 13. Okay. We now need to calculate our pivots. So we need to find our pivot so we can find our theta values. So we can see here the pivot's going to be in this column because we have the biggest negative number here. So the pivot in X column. Oops. So we need to calculate our theta values because we've got all positive numbers here. We don't do anything with P. Remember, these are our two objective rows. So we don't need to worry about dealing with those yet. So we're going to do theta 1, 10 over 1, which is 10. Theta 2, 5 over 2, which is less than 10. Now, as I said before, I like to keep fractions in, particularly when doing two-stage, because things get real messy. Okay, then theta 3 is 8 over 1, which is 8, which is not less than 5 over 2. So here, this is the least positive theta value. So the pivot is in row 2. And then we circle it to tell us that. Okay. Now we've done all the work we need to progress with the simplex algorithm. I'm just going to change pen so I can actually fit it all on one screen. Or on one page. Okay. So we have our first iteration. There we go. This is not quite as clear, but it means I can actually fit it all on one thing. So we have our basic variable. We have our variables x, y, z, s1, s2, s3, a1, a2, value, and row up. Okay. So those students who like to complain that simplex is really long, well, this is even longer. So there we go. Right. Before we start doing anything, let's use the graphics calculators. So, oops. Put in a matrix, that's previous simplex. So, here we go. So we have 5 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So big old matrix. And we enter it as before. 2, minus 3, 1, 0, minus 1, 0, 1, 0, 5. This is the bit that probably takes the longest. Oops. Like that, nothing happens there. Minus 3, 2, minus 1, 0, 1, 1, 0, 0, and minus 13. Okay, so we've got our matrix input there. So our first operation, if you remember, we need to take this number and turn it into a 1. We do that by dividing this whole row by 2. So our first row operation is a half row 2. So we're going to go row operations times by row. Oops. Now, as I didn't do in the previous video, I'm going to use fractions all the way through so that we don't get weird things with decimals later. Okay, and we're changing row 2. There we go, and we've changed it. So remember our basic variable, we had A1. This is going to swap to the pivot column. Okay, so the basic variable of the pivot row swaps to the name of the pivot column. So this basic variable is going to be X. We then copy down everything here. So minus 3 over 2, a half, 0, minus a half, 0, a half, 0, and 5 over 2. Notice again that the value column is the same as the theta value. That should happen. Okay, all the basic variables are then going to stay. The rest of them are going to stay the same. P and then I. Okay, so here we're just going to subtract one lot of, here we're going to subtract one lot of row 2 from this row. So we're going to have minus row 2 plus row 1. Okay, so we're going to go plus row, minus 1, row 2, row 1, and there we go. Okay, and then we write it down. So you can see really now why good use of the graphics calculator is really important for Simplex. Because it means that we do 5 rows of calculations in mere steps. Okay, so we've got 15 over 2 there. Then next one is the same but plus row 3. So we've got minus 1 row 2 plus row 3. 0, 5 over 2, minus a half. So you can see we've already got fractions in here, and a lot of them. Again, this is why the graphics calculator is really handy, because it means that we deal with the fractions and don't have to worry about them. Okay, so we keep going. Now the row operation for both of these rows is going to be the same, because you see we've got the same number here. So we're just going to do 3 lots of row 2 plus each of them. So 3R2 plus R4 and 3R2 plus R5. Okay, just doing that quickly. 3R2 plus row 4. Don't forget, you know what you're aiming for. You know you want these two numbers to be 0. So if they're not, when you type it in, you know you've done something wrong. Okay, so there we go. Minus 5 over 2, a half, 0, minus 3 over 2, 0, 3 over 2, 0, and then 15 over 2. And then same again, 3 row 2 plus row 5, 0, minus 5 over 2, a half, 0, minus a half, 1, 3 over 2, and 0. And we've already reduced I from minus 13, or we've increased it from minus 13 to minus 5.5. So we've already increased it a chunk. So we now repeat the whole process again. We can see we've still got a couple of choices in terms of our theta values. We can see here, this is the row, this is the column we're going to choose. You can see that this is the most negative number here, or the biggest negative number. We've got 2 of them. Now, it doesn't matter, strictly speaking, which you eventually... It doesn't matter that we're choosing the variables that we're probably going to be using anyway later on. They typically design it to do that because, well, they're not going to just get you to do simplex ad nauseum. You know, there's a process, and they're writing an exam, and they want you to be able to get marks. Okay, so although it seems like this is a really long algorithm and it's a pain, and to some extent, yes, they're not going to get you to do too much. Okay, but anyway, so we've got our pivot in the Y column. So we're not going to worry about theta 2 because we can see this is a negative number. That means we're not going to get a theta value. So I'm only going to bother to write down theta 1, which is going to be 15 over 2 divided by 5 over 2, which is 3. And then theta 3. Okay, we've got 11 over 2 over 5 over 2, which is 11 over 5. Okay, 11 over 5 smaller than 3. So here, this is the least positive theta value. So the pivot is in row 3, and we're going to circle that. There we go. We're now going to do a whole iteration again. Okay, so we've got, yep, there we go. So we've got basic variable x, y, z, s1, s2, s3, a1, a2, value, I'm going to call it v because I'm already running out of space, and I'm going to have row up here. Okay, so again, we want to make this number equal to 1. So this is where you need to be careful with fractions when you're typing things in the graphics calculator. To make this 1, we need to divide by 5 over 2. We can't type that in on the graphics calculator, so we need to write this as 2 over 5, row 3. Don't forget, if you struggle with fractions, that's fine. Because again, if you type it wrong, you don't get a 1 here. So you can just retype it and do it the other way up. Okay, but we should get 0, 1, minus a fifth, 0, a fifth, minus 2/5, minus a fifth, and 2 over 5, and our value again is the same as the theta value. Okay, now you can see A2 is no longer basic. Y is the basic variable here, and then again the rest of them stay the same. And then we just proceed with simplex as normal. So here our row up is going to be 5 minus 5 over 2 row 3 plus row 1 minus 5 over 2 . Now, if you want to kind of maybe potentially speed up your writing a little bit, you know what these columns are going to look like, or at least these three. You know they're going to be the same as up here. So you can just copy those in. I tend not to, just because I tend to use it as a nice way to check that I've done it all right. Again, don't panic that we get minuses here, that's fine. Okay, so we now have 3 over 2 row 3 plus row 2. Okay, so we've got 1, 0. It's also quite satisfying seeing a matrix develop as you go through it. It's the other reason I don't like to just write in the columns. It's weird, but that's just the way I am with this very long algorithm. Anything you can do to give yourself a little bit of enjoyment when you're doing it gets you there, makes it easier to do. Now, see, we've got 29 over 5. That's not a particularly nice number, but it's fine, it'll do. Okay, 2 things left to go. Again, we're going to do the same row operation for both. So we're going to get 5 over 2, row 3 plus row 4, and 5 over 2, row 3 plus row 5, and we'll do those individually. Zero, 0, 0, 0, minus 1, minus 1, 1, 1, 13. Now you can see here that in our P objective row, we've currently got no X, Y's and Z's. That's fine. That might change for Z's. Won't change for Y's because we've already made them basic. Okay, so these are probably not going to change again. Actually, they're definitely not going to change again. But we'll see whether our I row allows us to do that. Okay, so 0, 0, 0, 0, lots of zeros. Okay, so we can now see this is the first stage of the simplex two-stage method. We can see that our I variable has no minuses in this row, so this matrix is optimal. Doesn't matter that P's got some minuses in, we'll deal with that later. It's the I that we're worried about. We can see that the value of I is 0. And we can see here, because A1 and A2 are not basic, they are both of 0 value as well. What this means is we now have a basic feasible solution for our simplex algorithm because we've eliminated A1 and A2. If this doesn't happen, so if we don't get a 0 here, the original problem, this problem way back here that we're trying to solve, this one, has no feasible solution. There is no solution to this. Okay? Either that means P can maximize indefinitely, or there is no way to find a maximum value of P given these constraints. This is really important because sometimes if you're doing simplex professionally, you want to know whether you can actually find X, Y's and Z's that solves the problem you want to. If you can't, then there's no way for you to process or produce these things, so you need to change something. But luckily in this case, we can see here that we have a 0 in our value and this table is optimal. So there are no negatives in objective row, so optimal. Also, the value of I is 0, which means a basic feasible solution has been found. This is stage 1 complete. I'm just going to write that here so we you don't need to stuff that I write in pink when I'm doing this video, you don't need to write in the exam. But this is the end of stage 1. Because we have managed to make I 0. Again, if I isn't 0, then you can't do this. You finish at the end of stage 1, you don't go any further. You cannot find a feasible solution for the problem. We can. So what we do now is we take out all of the variables that we don't want. So we don't want the A variables, these artificial variables here, and we don't want I. The whole point of stage 1 is getting rid of them. So for the next simplex, or the stage 2 of this method, we use the table as here. So our basic feasible solution is P is 13, X is 29 over 5, Y is 11 over 5, oops, Z is 0, S1 is 2, and S2 and S3 are 0 as well. Okay? So this is the basic feasible solution for this now stage 2. So this is our starting point. So to continue, we just we copy down the tableau we just had, but we take out the A columns and the basic variable. Sorry, and the I row. So we've got basic variable, S1, X, Y, and P, X, Y, Z, S1, S2, S3, and value. So you can see we've already got a smaller tableau. We just copy down from above exactly what was there. Now we can see that we have some negatives in our objective row now. That means we're going to need to go again. If it happens that in stage 1 you end up with no negatives here after you've taken out the I row, then you've found the solution. That is unlikely to happen. Okay? Stage 2 of the simplex method is now just doing normal simplex on this. Okay, so I'm going to go through it just to go over simplex again. The useful thing about the graphics calculators is you can just delete rows and columns. So if you're on this menu here, we need to go back one. Okay, now the difficulty is you need to pay attention to which columns are which. So this is column 1, 2, 3, 4, 5, 6, 7. So these are columns 7 and 8. So we go to column and we go delete. And then this one has now gone. This one is now numbered 7. We can see we've got -1, 3/5, 2/5, 1, 1. So we delete that as well. We go up one menu and we're now going to delete the bottom row. So that means you don't have to retype the whole thing again, which is nice. You can double check. You can see we've got 7 columns, 4 rows. We've got 1, 2, 3, 4, 5, 6, 7 columns, 4 rows. Okay, so we're now going to do simplex on this. I'm going to move back to my thick pen so it makes it a little clearer. Okay, so we're going to calculate some theta values. So here we've got a choice of S2 and S3 because they're both -1s. In terms of which one you pick, either would probably be fine, because if you can see we're only going to get one theta value for each column anyway. Okay, you can see here we're going to get 2 divided by 0, which we can't do, and 11 over 5 divided by a fifth, which we can. So that's going to give us a theta value here. This one's going to give us a theta value here. So we get a half, and these two are minus. Okay, so it's likely that you would be told which to do, or they would, or they would sort out the question so that this doesn't happen. If it does and you're not told, oh well, pick one. Personally, I would pick S2 because it means we're likely to get rid of some of these fractions, possibly. Maybe not. But if we are, then we are, and oh well. Now the thing with this is, every further iteration should increase the value of P. So we see here P is 13. If you start decreasing the value of P, you've done something wrong. Okay, very unlikely that is going to happen. Okay, the only time that would happen is if we are trying to minimize Q, so therefore maximizing a negative number, which is a pain, but unlikely to do with this type of thing. But there we go. So I'm going to pick S2. Just because why not? All right. So we're only going to get a theta 3. And it's 11 over 5 divided by, 11 over 5, that's a mess. 11 over 5 divided by a fifth, which is just 11. Oh look, we're getting rid of all the fractions. That's handy. Okay, if we chose S3, this would probably still work. We just start getting, well, that doesn't necessarily get rid of the fifths. It just puts more of them in. If you want to try and get rid of fractions as quick as possible, then pick the one that's going to do that. So the pivot is in row 3. But hang on a minute, we already changed row 3 to Y. That's fine. That was a different objective row. So it doesn't matter. We're now dealing with this objective. So these basic variables are just our start point. So it doesn't matter that we're going to swap out Y for something else. That's just the way it goes. So not a lot you can do about that. It's just a case of, oh well, that happens. Okay, so got our basic variable, X, Y, Z, S1, S2, S3, value, and row up. Okay, so as before, we are timesing this whole row by 5. We've got 5, row 3. Okay, just double check, and we can see that row, that column 5 has become a 1, which is what we wanted. Okay, so we write that down. 0, 5, minus 1, 0, 1, minus 2, 11. Now this is something that makes students really uncomfortable, changing an objective row, or a column that was once a pivot before, back again. Don't panic about it, it's just the way it goes. There's not a lot you can do about that. That's how Simplex sometimes works. Okay, so the first row was already a 0, so we don't actually need to do anything about that. We just keep it the same. So just so that I have something here, I just tend to write down, oh, I'm using row 1 again. Okay, so we need to now type in a fifth, row 3 plus row 2. So we had minus a fifth here. So we want to make this a 0. We get 1, 1, 0, 0, 0, minus 1, 8. Okay, last one, you just get row 3 plus row 4. Equal 0, 5, minus 1, 0, 0, minus 3, 24. Okay, so you can see we're going to have to do simplex once more. Yes, this is a long question. Yes, we've done 5 different iterations, but there we go. So we're going to go through once more with the simplex. So we can see here that pivot's going to be in Z. No, it's not. It's going to be in S3. Sorry, my fault. Wasn't reading my table. So pivot in S3. You can see that this is just going to be a 1 here. So we still need to calculate the theta value. So the pivot's going to be in row 1. Okay, and we go again. We get S3, X, S2, P, X, Y, Z, S1, S2, S3, whoops, value, row 1. Okay, now we can see row 1's just going to stay the same again, which is handy, means you don't have to worry about it. Okay, we're now going to get one lot of R1 plus row 2. So we put that into our calculator and we keep going. Okay, so we can see here, got 1, 1, 2, 1, 0, 0, 10. Next one, we've got 2 lots of R1 plus row 2. Zero plus row 3. Okay, so that means I need to go back and change it. So 0, 0, and that's a 10. Okay, so that's what I'm saying. Just be careful with that. Got 2 lots of R1 plus row 3. So 0, 5, 3, 2, 1, 0, 15. And then last one, 3 lots of R1 plus row 4. Zero, 5, 5, 3, 0, 0, 30. Okay, we can now see that this is optimal because there are no negatives. In objective row. So therefore, the maximum value of P is 30 when X equals 10, Y equals 0, Z equals 0, S1 equals 0, S2 equals 15, and S3 equals 2. Now obviously if you have something with integer solutions, then you might have to deal with that at this point. Even if we did, all of these are integers, so we're fine. So this is how you do the simplex using the two-stage method. But I'll do another video doing the same example but using the big M method to solve this linear programming problem. Thank you. If you notice any mistakes, or if you have any questions or things you want me to go through from any spec, any unit in the Edexcel spec. I'm particularly proficient in the standard maths ones, the further maths, 2 core pures, decision 1, and further mechanics 1, but I'm sure I can figure out bits from the other questions. Thank you for watching, and goodbye.